Welcome to Writing an Interdisciplinary Research Paper, Part 2, Electric Boogaloo. In this section, I'll be talking about how to interpret scientific literature and talking a little bit about how scientists do their jobs. And for this, I have to get into a little bit of nitty-gritty, but not too much nitty-gritty. Don't out. So, look, I recognize that you're not a trained scientist. I'm going to presume that, right? I'm going to expect you to have the skills of a law student, not that of a scientist. So I don't expect you to conduct a deeply critical analysis of the scientific literature unless that's just what you set out to do. You don't have to do that. What you need to be able to do is to understand generally what those scientific papers are saying and be able to talk about them coherently. Again, if you ever have problems with a technical issue, even a seemingly trivial one, contact me, let me know. I'll resolve that difficulty, or I'll put you in contact with someone who can resolve the difficulty. Okay, we get to talk about scientific studies. You're probably aware of some of this information, but I want to make sure that we're all on the same page. So scientific studies are multi-step processes that involve the steps of designing the experiment, collecting data, and then evaluating those data to form conclusions by rejecting or accepting a hypothesis. Typically, experimental design will involve at least two conditions, a control condition and an experimental condition. Typically, in the experimental condition, an experimental manipulation is performed, and you want to see whether or not that experimental manipulation has an effect. Well, the hypothesis you propose for various statistical and theoretical reasons is that the experimental manipulation won't have any effect. Then you collect the data and see if the manipulation does have an effect. If it does have an effect, then you conclude your hypothesis here was wrong. In other words, that the experimental manipulation did indeed have an effect. The data sets from the two conditions are then compared, and the scientists calculate how likely it is that the hypothesis, namely that the manipulation will have no effect, is true. If the two data sets look the same, then the experimental manipulation had no effect. If they look different, let's say something became much smaller as a result of the manipulation, then those two populations of size should be different enough that we're able to tell them apart. How do scientists tell apart two different data sets? Like I said in the last slide, they evaluate the probability that both data sets come from the same population, which is to say the manipulation had no effect. Because they set up the hypothesis in that way, the probabilities are better if they're lower. Scientists will say the results were significantly different, and that is to say that the two populations are in fact different to a very high likelihood, and that the experimental manipulation was likely to have caused the difference. That last part is an inference, but generally, most times, a safe one. So you see that science progresses through the rejection of these types of hypotheses. But we have to be very careful in doing so. We have to really make sure that these two populations are different. So the reason, or the way that we accomplish that, is through the probability number. If the probability is less than 5%, i.e. p is less than 0.05, that the two populations are the same, that means I have 95% confidence that the two populations are different. All that is to say that probability value is very important. If the probability value is over 0.05, if it's 0.12, if it's 0.3, those results are not different. Let me say that again. If the P is either not reported or is over 0.05, then the result is not significantly different and it's not real. It may look real, but it's not real. These are the standards to which we have to adhere as scientists to maintain its integrity. This is often talked about in terms of type 1 errors and type 2 errors. This I'm just sharing with you because it's interesting for the pandemic and the testing that's conducted, and why it works and doesn't work, and what people are talking about with sensitivity and selectivity. But so I just wanted to also share this with you. False positives are type 1 errors. What's a false positive? That you say something is different when actually it's not. Type 2 errors are false negatives. You say something is not different, that the manipulation had no effect, and in fact, it did. So type 1, these are all different formulations of the same thing. Type 1 means that results appear statistically significant when they are not. They look like they're separate. They look like there's an effect of the experimental manipulation, but that is a false positive. And of course, then type 2 means that results don't appear significantly different or statistically significant when they are. And here's an easy way of remembering it. Type 1 error is the doctor telling the dude he's pregnant. The dude's not pregnant. Type 2 error is the doctor telling the woman she's not pregnant. Oh, but she is pregnant. And it's clearly a false negative. It's a false statement because the data support that. Here's another funny thing. Let's say your friend says you want to go on a date with a dude, and you say, sure, it's been a while since I've gone on a date with a dude. Well, then you cancel out. Well, you made a type 2 error because he'd be the best you never had. There's Marky telling you the truth. Okay, just to talk a little bit more about this topic, sensitivity is a statistical term, and it's been used in the pop press a little bit loosely, but really it means something very particular. It measures the proportion of the actual positives. In other words, it gives you a measurement of the true positivity rate. Is the study sensitive enough to measure a real effect? That you want your tests to be highly sensitive and at the same time highly specific. It measures the proportion of negatives that are truly correctly identified. It's the flip of sensitivity. It means the absolute true negative rate. Can the study you've designed discern outcomes accurately? Stated in terms of the pandemic, is the test sensitive enough to pick up even if you have a minor infection? That's sensitivity. Specificity is that the test is able to say, no, you do not have coronavirus. All right. Anyway, just thought that was interesting and maybe helpful for you as you go along.